Yeah, hello student. Yeah, this video is for some job interview purpose because as in many of the core core companies are asking the question related to the FEM, okay, or FEM or FEA, okay. So basically, the definition and what are the types of FEM, and again, what is meshing? What is meshing? And next, discretizing, and what are the different types of elements, and how the elements will be selected on what factors. So these are the some basic question we will cover in this video. Again, further question can be in the another videos. Okay, so as you know that a FAM or finite element analysis, that is the process of discretizing or process of dividing the domain or dividing the object into number of elements, that is number of finite elements, and applying the different analysis on the particular object that we call as finite element analysis. And now what is meshing? Okay, what is meshing or what is discretizing? So where the meshing or discretizing we can say here. So meshing or discretizing both are same. Okay, so meshing is a process of dividing that uh, domain or dividing the object into number of subdivision. Okay, number of subdivision into elements. Okay, so this results which will give the finite element analysis. So it is like dividing the element into number of uh, finite parts, number of the geometrical shapes. Okay, now this is very important to understand here. What is elements and what are the factors that will be decide when we are selecting the elements? So mainly the factors that will be based upon the geometry. Based upon the geometry, the different elements it will be selected. And second factor that will be based on behavior of the behavior of the object or behavior of the model, that is it will be depends. Okay, one is geometry and another is the behavior or working condition of the object. So based upon that it will be divided. Okay, now coming to what are the different types in the finite elements. What are the types of elements that will be generally used? As we know that there will be 2D element, two-dimensional elements. So two-dimensional elements are two types. One is a triangular element and another is quadrilateral elements. So triangular element again it will be subdivided into two types. One is linear, again is quadratic. Again in the quadrilateral, so there will be linear, again quadratic. Okay, so linear elements which will be connected all the elements. So these are the element 1, 2, 3. So all these elements are connected at their end. Okay, so 1, 2, 3 are the nodes. Such type of elements we call as linear. Okay, connected at their ends. So it is a three-noded triangular element. Okay, now we can define as it is a three-noded linear triangular element. So in a short we can say tri 3. Okay, it means triangular 3 elements. In quadratic, again it will be having one triangle, but at the ends anyhow you come to know 3 ends are connected. But middle of the element there is a one more elements will be added at each element. So it becomes a 6 node. So there it will be defined as tri 6. So that will be in the quadratic triangular element. Okay, now in the quadrilateral, so linear element, it's like in a rectangle. Okay, so here again all the elements are connected at their ends. That will be called as quadratic linear elements. So it is a four noded elements, quad 4. Now for the quadratic quadrilateral elements, so middle of the element it will be added one more nodes here. Okay, then it becomes 8 noded. Okay, total there are 8 nodes here, so quad 8. Okay, so these are two-dimensional elements. Now what are the three-dimensional elements? So here are the three-dimensional elements. Okay, so in short we can say 3D elements. So one is tetra, another is hexa, now penta. Tetra, hexa, penta. So these are the three-dimensional elements. So in tetra again there will be linear quadratic, hexa also same, and penta also linear quadratic. In tetra, so there will be four noded like a pyramid type. Okay, four noded tetra linear elements. So tetra 4. Okay, so there are four elements. So like pyramid, you can assume like a pyramid, four nodes are connected. Okay, so the base is in triangular element and there is a apex at their end. Okay, so this is a four noded tetra linear element. The shortly it will be taken in the software like TET4. Now quadratic tetraquadratic elements. So between the elements again it will be added one more element. So total if we added then it becomes 10. Total 10. Now for the hexa you know as cube hexa there will be 6. Okay. So here initially 8 nodes are used at their ends. Okay. Now these again at each element one more node will be added in the quadratic hexa noded, so it becomes total 20. So it will be denoted as hexa 20. Now for the penta, okay, so for penta it is 6 nodes. Okay, it is like a triangular prism type. Okay, it will be having 6 nodes and it will be defined denoted by penta 6. And again between the each element one more node will be added, so it becomes an 15, so it will be penta 15. So like that these elements it will be classified as 2D element and 3D element, and their classifications are like this. Okay, so thank you for watching this video. Again we'll come with the another video with different topics. Thank you.